Have you ever had a person, or perhaps an animal, accidentally or sometimes deliberately photobomb your pictures? This happened to me while visiting Minister's Island, and now I have this random tour guide guy in a lot of my photos. It can be funny. But this next picture must be one of the best photobombs in astronomy. Discovered in January 2025, Comet Lemon made its closest approach to Earth in October, when amateur astrophotographer Ela Sen captured this photo from Canakkale, Turkey. The little pinwheel galaxy, also called NGC 3184, peeked out from behind the comet from a distance of nearly 40 million light years. And a happy Canadian news story. Canada is increasing its contributions to the European Space Agency. The Canadian government announced this week that it will expand its investment in ESA programs by 528.5 million Canadian, a tenfold increase compared to previous contributions. Canada is the only non-European partner in the European Space Agency, an arrangement that dates back to 1979. And now for something else in the news. At first, I thought this report was an AI fabrication. Then I rather fervently hoped it was. But alas, it is the real deal. Take a look at this. Ben Nowak and Tons of Mirrors is solving solar energy's nighttime problem. His idea and company started gaining attention in 2024 and is now gaining more investors and traction with the planning of launching constellations of mirror satellites to illuminate and solar power our towns, countryside, and anywhere you can imagine on the Earth during the nighttime. A major selling feature is to the agricultural world, promising quicker crop growth and thus more profit. The idea is actually even older. Here's a paper from NASA from 1982. This paper is also quoted and listed on the Reflect Orbital's research page. Here's a little bit more from the website. Note the parts circled in red. Although at first the majority of people thought that this was a boondoggle of an idea not even possible, and there are some YouTube debunking videos on the very improbable chance of success, NASA released this on October 22nd. Reflect Orbital's plan to deploy 4,000 orbital mirrors reflecting sunlight to Earth alarms astronomers and ecologists fearing catastrophic light pollution impacts. California startup Reflect Orbital applied for FCC authorization to launch Earendel-1 in April 2026, a demonstration satellite deploying 18 by 18 meter mirrors reflecting sunlight to 5-kilometer ground areas. The company envisions 4,000 satellite constellation by 2030, providing light on demand for solar power extension and emergency illumination. Astronomers warn the system, producing beams 4 times brighter than a full moon, would catastrophically increase light pollution, disrupting astronomy, wildlife circadian rhythms, and nocturnal ecosystems already degraded by 10% year artificial illumination growth. Reflect Orbital's Sun synchronous constellation at 550 to 600 kilometer altitude would track the terminator, the day-night boundary, maintaining continuous solar visibility while passing over twilight regions, delivering concentrated sunlight to customers requiring extended daytime hours. Each 18-meter mylar mirror achieves 300 meters squared effective area, concentrating sunlight into 5-kilometer diameter spots, reaching illuminance levels comparable to civil twilight, according to company projections. The $1.25 million USAF SBIR contract validates potential military applications, including forward operating base illumination, disaster relief lighting, and extending solar farm generation into morning and evening peak demand windows when electricity prices spike. Over 250,000 service applications suggest market demand, though company revenue models remain undisclosed so far. So what happens when artificial stars cross observatory fields? The 18-meter mirror at 550 kilometer altitude subtends 3.5 arc seconds, appearing as magnitude -8 to -10 artificial star, comparable to crescent moon brightness, to ground observers within 100 kilometers of beam center. Unlike Starlink satellites creating brief streaks during twilight passes, reflect orbital mirrors maintain continuous illumination while tracking targets, potentially dwelling 2 to 5 minutes over 5-kilometer footprints, moving 7 kilometers a second orbital velocity. John Barentine calculates atmospheric scattering distributes 10 to 30% of reflected flux across 50 to 100 kilometer radius, elevating sky brightness by 0.1-1 magnitude during passes, sufficient to degrade photometric calibration, saturate wide-field survey detectors, and compromise time-domain astronomy detecting transient events requiring dark skies. So, why it matters for astronomy and dark sky preservation. Ground-based optical astronomy already faces existential threats from satellite constellations. 6,000 plus Starlink satellites create 20,000 streaks per night across Vera Rubin's Observatory's 3.2 gigapixel camera, with 100,000 satellites projected by the year 2030. Reflect Orbital's 4,000 mirrors add qualitative, different pollution, active, directed illumination rather than passive reflection, fundamentally brightening nighttime sky rather than incidentally contaminating exposures. Robert Massey emphasizes the philosophical distinction. SpaceX implements mitigation, dark sat coatings reducing brightness by factor 2 to 4. But Reflect Orbital's core business model requires maximizing reflectivity, making mitigation incompatible with service delivery. International Astronomical Union's CPS-1 Dark Sky Protection Committee estimates 4,000 mirror constellation would render 30 to 40% of professional observatories unable to conduct planned science, concentrating impacts on low-latitude sites near terminator regions where mirrors preferentially operate. Wow. Well, I wish Reflect Orbital just as much success as this next idea.